Hello, everyone. I think we're just about ready to start. I can't see anyone from here, so I'm just going to assume that there's people there. But it's great. I'm really pleased that you've decided to come out to this session. So today we're going to be diving a little bit into discovering credentials and secrets inside mobile applications specifically. It's a little bit of a roundabout story of how I kind of came up with this topic in particular. It was kind of a little bit of an accident when I was doing some other research, and I've found some really massive problems in pretty much how most people are building their mobile applications. So a little bit about me before we get started. My name is Mackenzie. I'm from Aotearoa, New Zealand originally, but I live now in the Netherlands, and I work for a French company called GitGuardian, which is based in Paris. If you want to follow me, you can find me anywhere at the handle @AdvocateMac. And I also have a podcast like everyone else. My mum says this one's fantastic, so you should definitely check it out. Called The Security Repo, where I dive into lots of topics with hackers and all kinds of other security researchers. So just a little bit of an outline of today. We're kind of going to be breaking it up into a few different parts. And we're going to be looking at how we can find secrets that relate to mobile applications. I'm going to start with how we can find them in source code, specifically, and how they leak through our source code. And then I'm going to do some discovery of how we can find them in our compiled applications, how we can decompile our mobile applications and pull apart credentials that we find in there. I'll do a bunch of demos of all these stages, so it'll be more than just a PowerPoint presentation, hopefully. But just to get everyone on the same page, I'll be using the terminology secrets a lot. And just in case you're not familiar with this term, basically this is a way of saying digital authentication credentials. It's typically things like your API keys, your security certificates, your encryption keys, anything that authenticates you to a service or allows you to decrypt or ingest data. The key difference with secrets and what we might call passwords, although you can have credential peers, and these are definitely secrets as well. But one of the key differences is that secrets are made to be used programmatically, and it's machine-to-machine encryption. An API key is kind of used by different services. A human isn't typing it in. So that's the kind of key difference. So what we're going to be discovering is these secrets, these machine-to-machine identifications. So how do we actually use these secrets? So modern applications have really fundamentally changed. A few decades ago, we built monoliths, these massive systems, these massive applications that needed everything to run. Now, thanks to the reliance on the internet, all these third-party services, and a change in architecture, we don't need to do that. If we're building an application, a mobile application, we can really focus on whatever it is that our application's doing that's different to what our competitors are doing. But there's a lot of stuff that our applications just need to do by default. And we can offshore a lot of that. So for example, if we've got credit card processing, maybe we'll use Stripe. If we're using authentication, maybe we'll use Okta. If you have some search functionality, maybe you'll use Angolia. If you don't want to manage your own database, maybe you'll get someone like MongoDB to manage it for you. And this helps us speed up our process, right? It makes our applications more secure in a way, and it also makes it a little bit more robust and scalable. The problem is that all of these services need to communicate with our application. So we do this through secrets. So we authenticate ourselves through secrets. Every single one of these logos or icons on here is a potential access point for an attacker. As an attacker, one of the things that I'm absolutely always going to be trying to find is these secrets so that I can move into different areas of your infrastructure. But once we've built our application, we need to host it somewhere. So we have secrets that deal with our infrastructure as well. Maybe that's on AWS. We have to manage our code, so we use GitHub or something else, some other kind of Git or version control system. Maybe we're using Datadog to analyze our data coming through. So again, we have lots more secrets that need to interact with our applications in some way. And all of these are, again, another attack point for attackers, another entry point for attackers. We also, once we've got our application up and running. We've shipped it off. We need to monitor it, right? We want to have integrations with Slack or Zendesk or Grafana to see dashboards. We want to see what's happening. The marketing team wants to know what's happening so that they can focus their attentions. And again, more secrets. And then we haven't even touched on all the microservices that we've created ourselves. So very quickly, you can see that an application, a mobile application, becomes a huge collection of all these different services. All of them are leveraging secrets to communicate with themselves. Now, as an attacker, one of the things that you first want to do is persist access. If I can gain entry into somewhere, I want to try and get entry into as many places as I can so you can't kick me out. So these secrets are really the crown jewels of our organizations, and we need to protect them at all cost. And as I'll show, that's not happening very well. So where should these secrets be stored? So if we're talking specifically about mobile applications, you can break it up into a few parts. You kind of have your front-facing application. So this is what you have on your phone. It's compiled into an APK or an IPA, depending on if you're using Android. And there should be no secrets in here. I should not be able to access any secrets that are stored on this mobile application. The only secrets that this should interact with directly are the ones that it creates itself. So if you want to encrypt data, you want to create an encryption key to encrypt that data, the application can do that, but it needs to create it. Any third-party secrets should never appear in your application. They should be stored in the back end, in local memory, like environment variables, and that back end should interact with your application. So either it accesses the data from the third-party services directly and sends it to your mobile application, or it can send an encrypted secret for your mobile application to use. This is a simplified version, but basically this is how we should be handling our secrets. The key point is that they should never be in the mobile application. But often, they quite often are. And this is a lot to do with what I can imagine is that applications on your mobile can be quite powerful. They don't really need a back end to run. But if you put secrets in there and you're not handling them correctly, then they're going to be very easy to exploit. So the first part is I'm going to look at secrets inside source code. And this is really how this topic came about. I was doing research into secrets generally inside source code and when they're found. And what I found was quite disturbing because I realized that there was a lot that actually involved mobile applications specifically. So every year at GitGuardian, we release a report called the State of Secrets for All. And this is essentially where we scan lots of places on the internet and we try and find how many of these secrets are out there in public spaces. One of the main places that we scan is this website here called GitHub. You're probably familiar with it. About 100 million developers use GitHub. And it's a really interesting place because even if your organization isn't using GitHub for its source control or anything else, the developers, your employees, are probably using it themselves. It's because it's used as almost like a portfolio. It's the largest place for open source code. So you probably have some exposure to it. Now, the data that's on GitHub is absolutely ginormous. It's the largest collection of source code ever. To give you an idea, last year there was over 1 billion commits that were pushed publicly. So I'm only talking about public repositories. I'm not talking about private repositories. So what's accessible publicly? There was over 1 billion commits that were made publicly last year by around about 90, and there's 94 million developers according to GitHub on that. And there was 85 million new open source repositories. So the amount of data on GitHub is an actual fire hose. So what we decided to do as GitGuardian, as a bit of a challenge, is we decided to scan all of it. So all those 1 billion commits that were made last year, we scanned them for secrets. And we found quite a lot. So in total, we found 10 million of these secrets out there in public places on GitHub. I'll show you exactly how we did that and what actually happens when you leak a secret on here. But this is huge. This is about a 67% increase from the previous years. So we know that there's huge amounts of secrets that are happening on there. Now, a lot of people will probably challenge this and say, how do you know that they're actual secrets? How do you know they're not test credentials? How do you know it's not some random high entropy string that looks like a secret? So we have individual detectors that actually find them. So we're looking for specific secrets. We have 350 detectors. And what we actually do is we validate them as well. So for example, if I find an AWS key, we will check that it's valid AWS key. So it's pretty crazy the amount of sensitive information in here. And I was kind of sifting through this when I decided to dive deeper into a little bit of mobile applications. But first, just have a quick look at what types of secrets we typically find on GitHub. So around about 24% are for data storage. So these are probably very sensitive, give me access to databases. Around about 20%, so about 2 million credentials that we found were for cloud providers. So this is giving me access into your infrastructure, your cloud infrastructure. Even if this is just a personal cloud provider account, I can still do lots of malicious things, like I can mine for crypto, I can use your resources to launch a malicious attack, so I can do lots of really interesting things with this. And we found lots more other ones. Messaging systems, these are interesting because you can do like an internal phishing campaign if I get like a Slack webhook or something. And we even found a lot of version control platform keys in public GitHub. So this is kind of like we've found your password for your GitHub account that you've put in your public GitHub repository. So it's quite alarming. And what I started to do is I wanted to look at where we found most of these secrets. So the number one there's a file extension. So the number one file extension that we find secrets is .py, this is Python. Then it's JSON and .env. So these are kind of data storage file extensions. So .env file is to store your environment variables. And this wasn't all that surprising, but then I started noticing that there was a lot of .properties, .xml, and .plist files. And I was like, oh, this is interesting. What are these for? And I realized that the majority of them were actually all for mobile applications. And when I looked into it, so for the XML, you have something like an Android manifest.xml. It's a place where you could store your variables and it kind of end up in your compiled application. And when I started looking at all the secrets that I found in these files that were specifically for mobile applications, I realized that it's bad to have it in your source code, it's bad to have it in public, but they should never be there in the first place. And if the secrets are stored in these files in the source code, that meant that they would be extractable from the application itself. So then I started looking into it and said, I wonder if I could start to extract these secrets themselves from the mobile application. So this is kind of what led me in this direction of looking specifically at mobile applications. So before we kind of get into that, just a little idea, like the common file extensions that we find. So for Android specific, lots of things. The Android manifest.xml is one that I talked about, build.gradle, strings.xml, and lots of kind of .properties. This is just a few. There's hundreds of more, but these are just a few of the interesting ones. I find it really interesting that someone would create a file called API-key.properties and then put it into a public repository, but never mind. These kind of are the specific files that we see, and all of these will get compiled into an APK, and they'll be extractable from that APK. And if we look at, I have a typo. This is Apple specific, sorry. But if we have the plist is kind of how Apple deals with it in their IPAs. So, Google services-info.plist. This one's actually really interesting because when I actually looked into this, one of the things that Google is great at making information really easy and digestible for developers. They make it really easy for you to get up and running and moving quickly on their products. One of the ways that they do that is they give you like a downloadable file for some of their services that you can plug directly into your application and get going. Now, everywhere on Google, it will say, this is sensitive, you shouldn't handle these secrets here, but basically their idea is that if we can get them moving up and quickly fast with our products, then they won't choose a competitor. And then what obviously ends up happening is people just plug it in, they go, oh, it works now, I move on to the next step, and that file ends up just compiled up into your application. So both Android and iOS or Apple have this problem. So I want to talk a little bit about how bad guys would actually find these files. So there's lots of ways to abuse GitHub to be able to find this information. Some are better than others. I'll talk about the easiest one and one that I kind of don't like. but it's the most obvious, so I'll mention it. And that's just using GitHub search feature to be able to find them. So for example, we could do a search here for file name, Android manifesto XML, and I want to find API key in here. But you could make that more specific. You could make it for an AWS key or a Slack webhook, and then you'll get lots of results. This isn't that effective. The reason why is that what you'll find is most of the secrets that are in places like GitHub are buried in your Git history. Someone's committed them and then removed them later on, thinking that that's gone, but actually it's there. The search feature doesn't look in the history, it just looks in the top layer. But there's lots of what we call dorks, so this is called GitHub dorking, and there's lots of dorks that you can just copy and paste into the search feature, and you're gonna find some stuff, you will, but there's better ways to do it. So a better way to do it, and now don't actually do it, but if, hypothetically, you could abuse the GitHub API. So a lot of people don't realize this, but when you make something public, it's not just public. We understand that if it's public, if you have the information, you can access it without authentication. We all understand that. On places like GitHub, it's not just public, it's broadcast. So for example, if we go to the address api.github.com/events, I'll just show you it here. This is it here. You don't need authentication for this. You can call this 60 times in a minute. Now this looks all mumble jumbles, and it is, but what this is a ledger of everything that's happening in real time on GitHub. So when something is pushed, it ends up in here. So I have the URL for it, but I'll also have a lot of information about the people, including their email address, where they might work. So I can really monitor this closely. So if I do a quick search to try and find someone's email, here you go. This is in the metadata. This is this person's email that's just in public on GitHub. So if I wanted to find a specific company, I could just filter out those domains. So I just like to show people, to show you that you can really just monitor all that's happening in GitHub in real time. And people do. There's a number of events that are published in this API, but the two interesting ones that attackers will look for are the public event. This is when a private repository is turned public. This is by far the most interesting, because if you're building on a project and you want to make it public, when you make it public, you make the entire history of that project public as well, which means if someone committed a secret on a dev branch a year ago, it's still there. And then the other one is the push event. So just to give you an idea of what actually happens here, what actually happens when you leak a secret, I'm going to leak a secret in GitHub, and we'll monitor what happens. So I have here an Android manifest.xml, and you'll notice here, not quite formatted correctly, but it won't matter for this, is I have an AWS credential. Well, now, this is actually a valid AWS credential, but if you want to do some crypto mining with this, you're going to be disappointed. What this is a honey token, and this is going to allow me to monitor traffic that people are trying to exploit this. So every time someone tries to exploit this credential, I'm going to get a notification. I'll get their IP address, and I'll be able to see what they're trying to do. So I'm going to commit this into GitHub, in public GitHub, and then what's going to happen is I'll be able to see on my dashboard everything that's happening with that token, and so we'll come back to that in a minute. By the end of this presentation, I can almost guarantee that at least 5 people will have tried to have used that credential on public GitHub. And I've made it easier for them. I've taken a sensitive file name, Android manifest.xml, so they don't need to search for everything, they just need to search for those specific files. And I've used a credential that's got prefix characters. So we'll see at the end of this presentation whether or not someone's tried to abuse that. Now, just quickly, before I dive a little bit more deeper into some other interesting, I want to show you an example of real-life breaches that have happened because of this. So the breach that I want to talk about is one that happened last year with a company called Toyota, obviously a car manufacturer. They have a mobile application called T-Connect. And what T-Connect does is it does lots of interesting things. It's quite sensitive. It can start your car for you, and it gives you lots of information about it. Toyota was working with a contractor on this T-Connect mobile application. What this contractor did was accidentally push code that was meant to be private to a public repository on GitHub. inside that code was the credentials for the database of the T-Connect server. Threat actors were able to find that and then launched phishing campaigns against everyone that was using the mobile application, and the attackers had a big advantage because they could really customize them. They knew that they were Toyota users, they could find out information about their car, and they could really target them specifically. Now, fortunately, a security researcher found this and alerted Toyota to it so that they could at least announce this and prevent further damages. But this is an example of a mobile application that where secrets were leaked that caused some real damage. So this isn't just a hypothetical. It does happen, and threat actors are monitoring this in real life, and are monitoring places like GitHub in real time to try and find these credentials. So I want to talk a little bit about private source code before diving a little bit deeper into the compiled applications, because I've talked a little bit about public source code, but I kind of feel like I need to talk about private source code. I really don't like the word private source code. I think it should be slightly less public source code, to be honest, because source code has a terrible habit of actually leaking out. So if you say to me, hey, this doesn't matter because where I'm building, we don't have any public repositories. No one uses GitHub, I question that, but we've got no risk of anything becoming public. But actually, source code is an incredibly leaky asset. And if you have any secrets in your source code, which I can almost guarantee you probably do, particularly in your history, then they will leak with your source code. So if we just take a few examples that happened last year, the Lapsus group was really prolific. They were looking into places like Microsoft. They leaked their source code. Samsung, NVIDIA, Twitch, Microsoft, all had their source code involuntarily open sourced. In that came with it a lot of secrets. So if you think that this is only a problem for people that are using it and creating open source software, it's absolutely not. If I take one of those, Twitch. So Twitch had their entire source code leaked, including all their mobile application source codes. And they had 6,000 repositories. We scanned it, and we found over 6,000 secrets in their source code that was leaked online via a torrent. So we found 194 AWS keys, 69 Twilio keys, 68 Google keys, and so on and so forth. So lots of sensitive information. And Twitch wasn't necessarily a bad example. They just had a lot of source code, so we found a lot of secrets. But I like to mention this because I feel like people have a false sense of security when it comes to private source code. To give you a breach example of how private source code can be attacked, there's one example that's really good. It's from CodeCov. So CodeCov is a code coverage tool. It does something very specific. It's when it tests how much of your application is being tested during the CI/CD pipeline. So it's a very specific tool. It would be part of hundreds of tools that you may use. It's quite a cool tool, but they had a pretty significant breach. So what ended up happening is CodeCov, how you deployed their application in your pipelines was via a Docker image. And in their official Docker image, they actually had some hard-coded credentials. That hard-coded credential allowed an attacker to manipulate their product. It allowed them to manipulate a bash uploader script and inject a malicious line of code. What that line of code did is it said, every time someone runs CodeCov, I want you to take all the environment variables and I want you to send them to us as the attackers. So how that affected other companies is that when you were testing your application, you need to compile it. So you need access to secrets. So those secrets will be living in your environment variables. A lot of them should be test credentials or like not for your production environment, for your development environment. But the ones that the attackers were after was access to private source code. So in that would have been access to your private code repositories. And what ended up happening was the attackers were able to leverage that so that all of CodeCov's customers, there was 20,000 at the time, they had access to their private source code. And their victims included Twilio, Monday.com, HashiCorp, Rapid7, lots of really big companies. I very rarely pick on any companies when they have breaches because I believe that they can happen to anyone. But I will pick on one company, and that's HashiCorp. So HashiCorp they are a great organization, and they build great tools. One of the tools that they use is a secrets manager called Vault. Vault is probably the top of the line secrets manager that you can get. HashiCorp invented the term secret sprawl. And their whole vision with Vault is that you would no longer need to have any secrets in your repositories because of this product. Because of the code cov breach, threat actors made it onto the private source code repositories of HashiCorp. And HashiCorp had to tell everyone that there was a breach because they had hard-coded secrets in their source code. So if HashiCorp has hard-coded secrets in their source code, none of us have any hope. And I want to stress that I don't think HashiCorp's a bad company. I think they're a great company. They probably have the best security. And this isn't really saying that they're bad. It's just saying that it can really happen to anyone. All right, so before we get into our second part, which we're going to look at compiled applications, I want to have a quick look at the experiment that I just did. And let's see if we can find this. So this was the secret that I leaked just a few minutes ago. Every single one of these, this is the IP address of someone that has tried to use it. So we can see the time requests. So 10:45, the first one happened at 10:38. So just in a few minutes, so in 7 minutes, we've had multiple people try and exploit it. We can see what they're trying to do. So here they're trying to see if the credential is valid, and we can see kind of what they're using to do it. So that's what happens when you leak credentials on GitHub. It happens very quickly because it's very easy to monitor it. So if credentials end up there, they will be kind of compromised. Now, what's interesting is, and a little bit out of scope for this talk, but I'll mention it quickly, is actually it's really interesting how these credentials are used. Because what happens is if you leak a credential, it kind of goes through a segment, almost like a hacker supply chain, where there's going to be one group of hackers that's scraping lots of information to try and sell it. So that credential that I leaked, I'm very confident because it was valid, will end up being sold on the dark web as part of a package. So these secrets will be sold. Another group of hackers is going to filter in that information. They'll separate it. They'll say, okay, I work for GitGuardian, so here's all the credentials that were related to GitGuardian. Here's the credentials that are related to Slack, and they'll sell them segmented. And then the last group will be a hacker that will try and exploit it. So what will happen if you monitor this traffic, there'll be a lot of people trying to exploit this secret originally to try and see if it's valid. Then it will get sold, and then there'll be about a few weeks later, I'll find another group of people that will have different traffic trying to exploit it. So it's just kind of interesting how these secrets are exploited, because if nothing happens immediately, if you're not breached immediately, it doesn't mean that it won't happen. It just means that that credential is kind of being passed through basically the hacker supply chain, let's call it. All right, so I want to get into the second part of the talk now, which is looking at secrets inside the compiled application. So we've looked at the source code. So up until now, we've been looking at kind of how these applications are being put together. But when I was looking in the source code, as I said, I noticed that there was a huge amount of files that were specifically related to mobile applications. And then I thought that if this is how they're building their mobile applications, surely I can extract them from the compiled application at the end. So there's millions of applications out there on the Play Store, on the App Store. But what actually are they? Like, what are these applications in their compiled form? What do they look like? We have this concept that if something is non-human readable, that means it's secure. That because when you compile an APK in your mobile application, because I can't open it up in VS Code and read it, that it's secure. That's absolutely not the case. What these applications are in the end, and there's kind of two different types. So if you're an Apple, it's going to compile it into an IPA. And if you're an Android, it's going to compile it into an APK. What actually are these files? Is they're basically glorified zip folders. And you can absolutely extract everything that's in there. Now, it might be a little bit obfuscated. I might not have all the original comments that you had that will help me navigate it. But absolutely, I can reverse that and reverse it very easily. And so if you have a secret in your source code that's made it into your APK, I'm going to be able to find it. And I'll show you exactly how to do that this time. So the first step is you just need to download the APK. You might say, oh, we can only download it on a mobile application. Very easy to get around that. Here's a free tool that I was using called gplay downloader. So this, you just put in the package name and you can download it. I then decompiled them with a tool, again, free, open source, called JDAX. And that just kind of allows me to be able to see all the original source code. And then I scanned that original source code with a tool called GG Shield, which is something that Git Guardian makes, which basically just will sift through all that information and validate any secrets that it actually finds. So I just want to show you very quickly what that actually looks like. I'm not silly enough to do 2 live demos, so I've recorded this. But essentially, what's happening right now is I have an APK there, app1.apk. I'm just going to use a tool called JDEX to be able to decompile this. That will just take a few seconds. When I'm doing this, it feels like it happens instantly, but whenever you're presenting it, it feels like it takes about an hour. But within a few seconds, we have the decompiled version. And then if we open it, then we can see this is all the source code. This is all the files that we have in here. So anything that was used to compile it, there's a version of that in here. Now, they might not have all the same names, but I can definitely see everything in here. Now, if I wanted to, I could sort through all this manually. I could look at the strings.xml file or the Android manifest and find secrets. That's where they most are. But I'm lazy, so what I'm going to do now is I'm using GG Shield to do a secret scan on this app. Now, I just want to say that this application is one that I downloaded from the Play Store. I chose this one. I downloaded about 5. So this is not like I didn't search the Play Store for the worst example. In fact, I specifically didn't pick one because I thought that it was probably a little bit too bad. So what's happening now is it's scanning through. There's areas that it's getting is because there's a lot of media, so videos that it can't scan. But once it gets to the end, we're almost there, we're at 80%, it's going to spit out any secrets that it's found. And so again, this is a real example on the Play Store. Now, I didn't do much investigation, so exactly how bad all of this is, it's definitely bad, but exactly what everything does, I haven't looked. So we have here, if we have a look, we have here a bunch of secrets. So we have some generic passwords. These probably could be false positives. We won't look at those too much. But immediately, if you look down, we have a valid Slack webhook URL. So this means that I can perhaps ingest some messages coming through. At the very least, I can post something. Again, just below the Slack webhook, we have some generic passwords again. Again, could be a false positive. I didn't look too much into it. But it gets much worse. And then we start getting into some good stuff. We have some Google API keys. So this one could be for Firebase messaging, or it could be for Google Buckets or something like that. Again, this is valid, which means that it's not locked down. It doesn't have the correct permissions to be able to prevent me from using it. So in fact, we found a couple of those. This one was in a .java file, so we know that it's hard-coded, that it was hard-coded into the source code. And we find some more Slack webhooks, and so on and so forth. We don't need to go through all of them, but we found a lot. And this is just from... Oh, I forgot that I was... There we are. All right. So that's just one example of how easy it is. Within a few minutes, you can decompile an application and find any sensitive information that's inside it. Tools like GG Shield help you because they can validate things for you, so you end up with it. And that was just a random example. And those tools are all freely available. You can literally do this. It will take you 10 minutes to get it all set up, and you can do this after the presentation if you don't believe me. And I can guarantee that within a few applications that you try, you will find something that's interesting. All right. Now, the other side of thing, that was looking at Android. The other side of thing is Apple. Now, surprisingly, Apple's actually a little bit even easier than decompiling APKs. So first of all, you need a tool to be able to download the IPA because you're not on a mobile, so that's very easy. IPA tool, conveniently named. And then you don't even need a tool to be able to decompile an Apple application. All you need to do is change the file extension from .ipa to .zip. So when I literally said that they're just zip files, they're glorified zip files, in the case of Apple, it's not even glorified. It's literally just a zip folder. And then you can do that, and you can get all the information from that mobile application. And then again, I just use GG Shield to scan it. So I don't do a demo. interestingly enough, Apple is better than Android for how many secrets that we actually find in there. At the moment, doing some more detailed research into Apple specific, but still plenty of tools that have hard-coded secrets using Apple. So again, what I want to do is I want to use an actual example of a breach that's happened using this method. This one, it comes from a friend of mine, Jason Haddix, who's a penetration tester. He's the former CISO of Ubisoft, and he still hacks things for fun, but he is a white hat hacker, so he does it for good. But he managed to find some crazy credentials involving an unnamed financial institution. So it was a bank. It was an application for a bank. So to start with, he downloaded the bank mobile application and was playing around with it. And then one of the features of this application was that you could take an image of a check and get that check cleared. So having checks is pretty sensitive. After doing some more discovery, he realized that these images weren't being encrypted in any way. They were just being stored kind of in plain file in local memory. So that got him an idea. He then started scanning that application for secrets and found a hard-coded Amazon S3 bucket access key. So this just gave him access to that bucket. That happened to be the bucket where these checks were being stored. He accessed that bucket and found 10,000 images of checks that were unencrypted from customers of this bank. So this is a real-life example of a pretty significant breach of lots of information that happened because of hard-coded secrets. So this isn't just random applications. Maybe it's like some student's project that he's put on their Play Store. No, this is happening across the board with massive consequences. And you'll notice there's been a huge increase in mobile applications that use OpenAI, so like ChatGPT type thing. And what I discovered is that 100% of the mobile applications that use OpenAI had their OpenAI API keys hard-coded into the applications. So if you're looking for API keys to use that, that's a good place to start. Don't do that, obviously. So I started to do some research to see how big of a problem is this, wide-scale research. And I was about to start, but I realized that there was some done before me. So this one, they looked at 12,000 Android applications. And then Cyber News last year did a great research study, and they looked at 50,000 APKs on the Play Store, downloaded from the Play Store, and see how they had secrets in them. So I teamed up with the guys at Cyber News, and we did a full webinar on this research and all the methodologies and exactly how they did it, how they chained the tools together, and all their results. If you want to see that webinar, there's a QR code there. But I'm just going to present a few slides from it because obviously we don't have time to go too deep into what their research was. But the main things, out of 50,000 applications, how many do you think contained hard-coded credentials? It was nearly 56%. So more than half the applications on the Play Store contain a credential. Now, if you're familiar with using Android or mobile applications, you'll probably challenge this and say, okay, but surely not all of those are valid credentials, or surely not all of them are really that sensitive. And the answer is, yeah, there's definitely levels. Not all of them are going to give you access to an S3 bucket that contains images of thousands of checks. But what it shows, and if I'm looking at this as an attacker, is that there's no reason for any secrets, even if you restricted them, even if you're signing the service with your application, there should be no secrets in your application. There's no reason. You can debate me afterwards. I'm happy to hear arguments. I've heard lots. But I still don't believe there should be any reason for it. So the fact that there's going to be secrets in there means that you have some poor coding practices, and it means that as an attacker, I will get excited because now I have an avenue that I can research down and try and find different ways of doing it. So, but this is an absolutely huge problem. If we actually look at the secrets that we found, so again, very long list here, but Google storage buckets were the number one, the number one kind of secret that was found in this. So this is kind of, this is pretty in line with the breach example that we saw from the bank. So that used buckets as well. That was an Amazon bucket, but here, Firebase URLs. Now, these aren't always incredibly sensitive, but unless you've perfectly configured your Firebase instance. So Firebase is for messaging, if you're not sure. So there are a way to kind of store a Firebase URL with it not being sensitive, but as an attacker, it gives me more information. And if you have any misconfigurations or haven't set up everything perfectly on the Firebase side, I can abuse these to try and conduct a man-in-the-middle attack or at least disrupt your service. And then lots of other really sensitive secrets as well. And this one here, maybe it doesn't surprise you so much, but the industries that leak the most amount of secrets, health and fitness was the number one. But actually what this kind of shows is it's kind of across the board. None of them are doing particularly well. There's 55% of applications are leaking some kind of secret. None of them are kind of doing all that well. So we can see that this is a really big problem. And so what started off as me kind of wondering why .properties and .plist files were leaked in GitHub ended up revealing that there was actually some pretty fundamental flaws with how we're storing secrets in our mobile applications. So now the question is, how do we do this securely? If we've got an APK, an Android file, how do we actually store our secrets securely so that they don't leak? And the answer is that you don't. You don't put them in your APK. At the start, I kind of showed you an example of your mobile application that talks to your backend and sends you the information. Now, this doesn't include secrets that your application makes, as I said. So if you're going to encrypt something, it needs an encryption key to do it. It can create that encryption key and store it in hardware on the phone. That's a secure way. But when we're talking about third-party services, you should not store them. You should log into your backend via an interface and get the information from there. So store the secrets on the server side. Now, I get lots of pushback from this, from people that, okay, but what about, and this is, and so the first one is encrypting it in base 64. So this is just kind of making an extra step for secrets. Splitting keys. So what if I store one part of the key here and one part of the key here, and then the mobile application puts them together? A lot of people say, what about if the keys aren't sensitive? So an example that I get from non-sensitive keys are things like, okay, it's just a Google Maps API key. Like, what can you do? But actually, even with non-sensitive keys, you can still do a lot, depending on how non-sensitive they are. Application keys, we've talked about that. These are the ones the application actually creates. And then people are like, what if we obfuscate our code so that no one can see what's happening? So most of these are useless. Base 64 is not even a road bump. The tools that I use will decrypt base 64 and find the secret automatically. It's not even an extra step. Splitting keys, it makes it slightly harder. But I'm still, if I'm in your application and I'm motivated, I'm still going to be able to see that there's a partial key there, or that I can see that the keys are being put together. So yes, that will make it slightly harder for me, but if that's what you're relying on slightly harder for your security, then that's a very bad approach. Non-sensitive keys, so like Google Maps, API keys, weather tokens. So Google Maps doesn't really have a free tier anymore, but it's very cheap. So you put up a Google Maps on your application or something like that, and you hard code the key. Every time that Google Maps does something, it charges your credit card just a tiny little bit. So you've given me, as an attacker or your competitor or someone that really doesn't like you, basically a button I can press that's going to charge your credit card every time I use it. So if you have set up so that you have limits on your payments, then and you should, then it's going to disrupt that service. So yeah, that's not the end of the world, right? It's kind of a nuisance. But I mean, that's still a problem. And if I see an API key like that, then I know that you've probably got some poor coding practices, and I'm going to be diving a lot deeper than I would in a general look. So it's a red flag. Application keys are fine. You store them in the key store in Android or something else. And code obfuscation, I'd say it's useless. Some people, it maybe make it slightly harder. But again, not useful. So when you're talking about obfuscation, like here's an example. There's this option when you're making Android where you can minify. So minify your code means it's going to make it as small as possible. You set this to true. It means that it's not going to be as pretty once I've exploited it. But I'm still going to be able to see it. And if I run secret scanners through it, they don't care. They don't care if it's readable or not readable. They're just going to find the secrets. So obfuscation is absolutely not enough to hide your keys and won't stop really anyone. But there are some things that you can do. So limit your scope. So sign your application. so that requests being made are done so that they know it's from your application, and then you can reject requests that are made from me as an attacker just using it. Limit IP addresses to your known, to known machines. So if you know that this key is only going to be used from this service, then limit it down there, and then limit the API keys to their absolute minimal scope. What I see so often is that you have a key to access, to be able to pull information from one particular Amazon S3 bucket. But for whatever reason, that key has so much permissions that you can put stuff in that Amazon bucket. Maybe I had one example where the key was just allowing me to read images, but it was an admin key and enabled me to be able to create a new user from that. And then I had an admin user that no one knew about in this system. So there's really, I can't stress enough that you limit it. And then also set up rules wherever possible of what keys are allowed to do. So an example is Firebase. Firebase has come up a lot. You can restrict access by adding security rules on Firebase. So here is where some people say, okay, but I have Firebase keys in my APK, but I've set up Firebase rules. You can't really do anything with these keys. That may be true, but it relies on everything being configured perfectly 100% of the time. And I know from experience that it is so easy to make a misconfiguration. You have one person that changes something in a YAML file, that comments something out, and all of a sudden everything's public, and your rules won't protect you. So if you're just relying on everything being configured perfectly 100% of the time and then hard-coding your keys in your application, you're absolutely allowing a vulnerability that could potentially be there. So this is why I always say that it doesn't matter what the keys are, they shouldn't be accessible to me as the attacker. So why does this happen? So everyone probably came in here thinking, okay, but surely no one's that stupid, right? No one's going to put a key in public GitHub. No one's going to put a key in a compiled APK or on the Play Store or on the App Store. But it happens. So why does it happen? So when we're talking about code, the biggest scenario that I see is that code is secrets are committed for testing purposes. So let's say I have a challenge for you. I say, okay, I want you to connect up to this database, this service. I just want you to do it quickly. And the developer goes away, he gets his keys, he hard codes them in because all he's trying to do is get something working quickly. He's working on a development branch, no one else is seeing what he's doing. He gets it all running and then he removes the keys because he knows that's not what you meant to do, but he's got it working now. So he can remove them, put them as environment variables. So all of that is, number 5 is missing. I don't know what happened there. But so all of that is kind of what happens. That key lives in your Git history forever. So it doesn't matter if it was removed. The fact that it was there in the first place means that it's going to persist there. We have this assumption that compiled apps are reversible, so that they're non-human readable means secure. We've just disproven that, hopefully well and truly tonight. So if you put something in your APK, I can reverse it, I can get it back. We've got secrets that are printed out in log and generated files. So if you're doing some debug logs, one of the things that might happen is it will give you a printout of your environment variables. If you then go git add all and capture those logs into your repository, those files are now in your repositories. And they have even seen it where log files have ended up being automatically compiled into an application at the other side, which is weird, but it happens. Sensitive files just included in repositories, so just putting .env files in there. If you want to prevent secrets in your source code, make sure you use .gitignore files and ignore anything that could be slightly sensitive. Number 5 there is, I don't know why the title's gone, but basically it's people using their personal GitHub accounts. GitHub is interesting because you often share one account. If you're using it for your work and for your personal use, you have one account that's split. Very easy to accidentally send something to the wrong place. And then the biggest reason, number 6, is that we're still just seeing secrets being hard-coded. It's just the number one reason that I can see is that I try and give everyone credit with coming up with these scenarios of why it would happen, but actually they're just putting them in their source code. And then they're compiling their application and then they're shipping it out. So there's still the number one reason why secrets are ending up inside our applications, inside our source code, is because we're just putting them there. We're not handling them correctly. So how do you prevent secrets from being leaked? So the first step that I say is change your mindset a little bit and assume that you will be breached. So assume that someone like me is going to take your APK and try and reverse it and try and find different information from it. Once we adopt that, then we change our mindset a little bit. And then we actually start looking at, okay, so if I'm assuming that someone's trying to attack me, if I'm taking the posture that someone's going to get into my source code, how differently do I think about things? So that's kind of the first step, because that changes your mindset. Number 2, use automated secrets detection. There's lots of tools to do this. I work for a vendor, so I won't mention them, but there's lots of open source tools that will use secrets detection. So if you don't have budget for it, if whatever, there's free tools available. There's no reason why everyone shouldn't be automated their secret scanning. Once your application is compiled, you can scan it. Once you got it in your repositories, you can scan your repositories in real time. So you absolutely use automated secrets detection, because secrets end up in places that is weird, that you wouldn't expect, and often people just don't have visibility over it. Restrict access, so we've talked about this, whitelisting services, narrowing it down so that only, as much as possible, keys can only be used for their one job by the services that they expect. But honestly, this doesn't happen that often. An interesting one, I used the honey token to prove that people are kind of abusing the GitHub API. One good thing that you can use these honey tokens for is to create them yourself and then put them in your infrastructure, and then you'll at least know when someone's trying to abuse you. If you put them in your source code, you put them in the APK. I'm conducting an experiment at the moment where I have honey tokens in compiled applications on the Play Store, and I'm seeing if anyone's going to try and abuse them. So it's interesting because that's something that you can do proactively to know when you have a breach. One of the biggest areas of attack is that once I'm in your system, I want to stay in there for as long as possible and persist access. So it may be a month, it may be a week, it may be 3 months that I'm inside your system before I do anything. So you want to know about it as soon as it happens. Ensure all your secrets are server-side. I've mentioned this about 800 times. So please don't put them in your APKs. Don't put them in the front end. And the last thing is use infrastructure as code scanning, or use infrastructure as code. And the reason is that what I've noticed is that we're really relying on our infrastructure being perfect all the time. With things like Firebase and having those keys in there. So one way we can ensure that is that we codify our infrastructure and we scan it for vulnerabilities so that we have less chance of making a mistake. But again, I really wouldn't rely on having your infrastructure perfect as a way of obfuscating your keys. And that's it. If you want to look at the State of Secret Sprawl report, this is a report that looks at GitHub. There's a code, you can scan it there. There's also a white paper on how to maturely manage your secrets. So if you want to know where your organization sits as a benchmark and all the tools that you're using, there's a cool survey that you can do that will spit out how mature your secrets management programs are. I don't think questions will work here, but thanks everyone for listening, and I'll be around afterwards, so feel free to come ask me any questions that you have or challenge me on anything that I've said. So thank you all for listening. It's been fun.